let's see this example 6. It's a very good example. So it says that under root 1 minus sin x upon 1 plus sin x will be equals to some value which depends on the range of x. So if x lies between minus pi by 2 to plus pi by 2, which means first and fourth quadrant, right? And pi by 2 to 3 pi by 2 means second and third quadrant. Okay, so don't be confused how minus pi by 2 came, because if you go anti-clockwise, so it will be positive, and if you go clockwise it will be negative. So plus pi by 2 means this, minus pi by 2 means this, and so you cover the first and the fourth quadrant in the first case. Okay, now let's simplify this. 1 minus sin x upon 1 plus cos x, 1 plus sin x. So now you will notice that I have mod of 1 minus sin x upon mod of cos x. Why? Because inside root the quantity should be a positive number always, because root of a negative number is not a real number, which is an imaginary number. So under root of a square will be mod of a. Now if you look at the numerator, it is 1 minus sin x. So sin x lies between 1 to minus 1, minus sin x will lie between 1 to minus 1, and 1 minus sin x will lie between 2 to 0. So it will always be a positive number. So we know mod a is equals to a if a is greater than or equals to 0, and is equals to minus a if a is less than 0. This is the mod property that we know. So I can remove this mod. It will be 1 minus sin x, because we know that 1 minus sin x will always be greater than equals to 0. Now you have mod of cos x. Now okay, let's look at cos x. Cos x will lie between minus 1 to 1. Okay, please include the equalities too. Okay. Now I cannot say that cos x will be only positive or cos x will be only negative, because it could be anything in between minus 1 to 1. So now in order to open this mod, I will use the modular equation property, that I'll divide it into two parts. 1 minus sin x upon cos x, when I know cos x will be positive. Cos x should be positive. And 1 minus sin x upon minus cos x, when cos x should be negative. Okay, how did I do this? Using this property. Okay, now okay, in what all cases is cos x positive? So all positive, here cos is positive, and here cos is positive, which means in first quadrant and fourth quadrant cos x is positive, and in second quadrant and third quadrant cos x is negative. Using this analysis, I can write this whole equation is equals to 1 minus sin x upon cos x if x lies between first and fourth quadrant, which is pi by 2 to minus pi by 2, and the other part 1 minus sin x upon minus cos x when x lies between second and third quadrant, which is second quadrant starts from pi by 2 and third quadrant ends at 3 pi by 2. Now let's simplify the fraction. It will be sec x minus tan x for all x lies between pi by 2 to minus pi by 2, and minus sec x plus tan x for all x lies between 3 pi by 2 to pi by 2. And this was what we needed to prove. So you have to keep in mind once you open once you do under root square root of something, it comes to be mod of that quantity. So now you have to be careful while removing the mod and writing down the equation.